Hi, welcome to CHEM 2330, Fundamentals of Organic Chemistry. In Chapter 1, we are going to do essentially a general chemistry review. We are going to review all of the topics from Gen Chem 1 and 2 that you're supposed to still remember and be able to use. One thing that you'll notice about chemistry as you move into organic chemistry is that chemistry is a very cumulative field of study. So there are things in Gen Chem 1 and Gen Chem 2 that you're expected to recall and be able to use proficiently in organic chemistry. And as we move through organic chemistry, you'll notice that there are things that you're expected to recall from Chapter 2 and Chapter 3, even as we get into like Chapter 14 and 15. So in this chapter, we are reviewing those things that you're supposed to know before you start organic chemistry. Because it is a review, these videos may not be as in-depth as you need for each topic. If that is the case, please let me know. You can always ask questions in class, you can send me emails, you can come to office hours, and I'm happy to either explain things more in depth one-on-one or direct you to other videos that may be able to help fill in some of those gaps for you. The first question that we need to answer before we can move forward is simply, what is organic chemistry? Organic chemistry is the chemistry of compounds that contain the element carbon. It's a very simple definition because it's a pretty broad answer. Organic chemistry is the study of anything that contains the element carbon, but we're also very interested in how different compounds are made, how those reactions occur, and explaining how those reactions occur. To just kind of give you an idea of what types of compounds we're going to be looking at, I have kind of a silly list of organic compounds here. So the first one here is methane. Methane has the formula CH4. It is a very small organic compound. Methane gas is not really something that you think of when you hear the word organic typically. You may be thinking more like fruits and vegetables that don't have pesticides. And methane gas kind of sounds like not that. Propane gas, something else that you may use if you're really into barbecuing, is also an organic compound because it has 3 carbons. Tryptophan is an amino acid that gets talked about a lot when we get to about November because people always like to blame their sleepiness after eating turkey on tryptophan. We haven't learned how to read structures like this yet, but you can see that in this compound, every single one of these little bins is actually a carbon atom, and we're going to learn in this chapter how to read this type of structure. Leucine is another amino acid. Cholesterol is also a compound that contains quite a few carbons. This one is added kind of for the silliness factor. Every single one of these bins that you see is a carbon. I'm not going to circle everything, just kind of give you an idea. And cholesterol is kind of far from what you may think of when you think of organic compounds. And to get a little sillier, cocaine and methamphetamine are also organic compounds. Now, organic compounds encompass a much larger area than this. If you're sitting in a chair right now, you're probably sitting on like a styrofoam cushion wrapped in fabric. That styrofoam cushion is a polymer that has many, many carbon atoms in it. The fabric is possibly polyester, which is another polymer made from carbon-containing compounds. You are organic because you have carbon-containing compounds in you. There's carbon everywhere, so organic chemistry is really a pretty broad subject. So there is a field that is often easily confused with organic chemistry, and that's natural products chemistry. So to kind of explain this, there was a concept called vitalism that said that organic compounds only came from living organisms. But that's not true at all. There are plenty of compounds that contain carbon that do not originate in living organisms. In 1828, Friedrich Wöhler synthesized urea from ammonium cyanate. This was the first synthesis of an organic compound and also the beginning of organic chemistry as a scientific field. So it's his fault that you're in this class. You can see here we have ammonium cyanate on the left-hand side. It's just a salt, but it has 1 carbon atom there. And upon heating, these atoms are able to rearrange essentially to create urea. Natural products chemistry is the study of compounds that are isolated from living organisms, and that's totally different from organic chemistry. So natural products chemistry is you go into the Amazon rainforest and you take a sample of bark from a tree, and then that tree bark is analyzed and you find all these different compounds and you isolate them, and then maybe you also test them to see if they have any cancer fighting properties. That's natural products chemistry. It's a very important field. It's related to organic chemistry um, in the sense that organic chemistry can be used to look at that compound and figure out how we could synthesize it in a mass production kind of way and avoid chopping down the entire Amazon rainforest to cure cancer. Organic chemistry allows you to take those natural products and make them widely available. You can tell I didn't know my slide was going to advance, and the recording mechanism would not let me go back for that. And I did not want to record the slide again. I promise this will be the least professional of all my videos. So I'm on the last slide of this video. It's a pretty straightforward one. I'm just giving you an outline of this course. So what is the purpose of this course? This is something that we'll talk about more when we actually meet for the first time, but here is a little outline in case you want to come back to this. CHEM 2330 is designed to give you a broad yet complete understanding of organic chemistry. So if you look at all the chapters that we're going to cover, you're actually going to cover pretty much everything that's covered in Organic 1 and 2, but you're going to do it in one semester. And if you're taking this over the summer, you're going to do it in 4 weeks. That's pretty intense. That's quite a lot. We don't cut out a lot of material. You'll notice that there is no chapter 11. That would be spectroscopy. That's not something that we bother covering in this course. Chapter 16, don't even know what that was going to be. I think it was polymers maybe, but we skip to carbohydrates. I've broken this down into what is typically covered in Organic 1 and what is typically covered in Organic 2, so you can kind of keep track of where we are in the course. You'll notice that this course moves very fast and it can feel very intense and very difficult. This may not be helpful to hear later in the semester, but we are not covering these things at the same level that you would have them covered if you were taking Organic 1 or Organic 2. You will not be taking the American Chemical Society final exam. This course would not prepare you for that. We are going to cover everything that's covered in Organic 1 and 2, but at a simpler level. Now, when I say that, that makes it sound like it's going to be easy. That's kind of similar to me saying, we're going to learn the fundamentals of brain surgery. Brain surgery is still a really intense and difficult field, and even taking the fundamentals of it would still be a really challenging course. So I want you to look at this as, yes, it's kind of a survey course, but it is going to cover some really difficult topics and it is going to require a lot of time. Organic chemistry gives you the concepts and terminology needed to understand biochemistry and animal metabolism. This is especially important if you are in the nutrition field or wildlife biology. A lot of that chemistry doesn't really show up until we get about here. So unfortunately, that kind of means you have to get your entire way through Organic 1 and 2 to get to here, right? While the material, again, is not presented on the same level, you do learn all of the same material with only a couple of exclusions, and that's going to be some challenging reactions here and there, and spectroscopy are the exclusions. Anyway, this is the end of part 1. This is just an introduction to this course.